Guys, Mr. Patterson here with another video for IB Math AAHL. Today we're taking a look at section 12I, the vector between 2 points. Pretty straightforward lesson here. We're just going to, instead of finding position vectors, which are vectors from the origin, we're going to find the vector that connects 2 points. And we're going to look at that in 2 and 3 dimensions. So if we take a look at this example here on the right, we see vector A, which is really vector OA because it comes from the origin. And we see vector B, which comes from the origin going out to point B here. But if we think about those together and we want to try to find vector AB, meaning the vector that starts from point A and goes to point B, we could use some analysis here. We've seen this diagrammatically before. If we did try to go from A to B, we could do negative vector A plus vector B, which is really the same thing as saying vector B minus vector A, which if we want to find what that vector is, all we have to do is subtract their components. So we've seen this before, now we're just kind of putting it into practice in an actual vector here. So if we're looking for the displacement vector of B relative to A or from A, we call it vector AB, and it is vector B minus vector A. So we do the end point or the terminal point minus the starting point or the initial point. All right. And we can get it by, like we said, just subtracting their components. So let's take a look at a couple of examples here. We have points A, B, and C, and it says find the displacement vector of B from O. O is always going to be the origin. So B from O is just going to be that point B minus the components from the origin, which are going to be 0 for both of them. Therefore, vector OB is the same thing as the coordinates of B, 3, 4. Because how do we get from the origin to point B? Well, we are just going to go right 3 units and up 4 units. If I'm doing B from A, I'm just going to take the coordinates of point B, and I'm going to subtract the coordinates from A. So it's going to be 3 minus negative 1, or 4. 4 minus 2, 2. So that vector AB has the component form of 4, 2, which means if I want to go from point A to point B, I just go right 4 units and I go up 2 units. Similarly, A from C, I'm just going to subtract vector A minus vector C. So it's going to be negative 1 minus 4, negative 5, 2 minus negative 5, or 7. If I have 3 dimensions, no big deal. I'm just going to subtract all 3 components. Take a look at this example 21. Same idea until we get to question C here, which is a magnitude question. No big deal there. Vector OP. Okay, so we're going from the origin to point P. So I'm going to take all of the components for point P, and I'm going to subtract 0 from them, and I get negative 3, 1, 2. Vector PQ, I'm going to take point Q, and I'm going to subtract point P. When I do that, 1 minus negative 3 is 4. Negative 1 minus 1 is negative 2. 3 minus 2 is 1. And then in part C, if I'm just trying to find the magnitude of that, I'm just going to take 4 squared plus negative 2 squared plus 1 squared, and I'm going to square root all of that, and I end up getting root 21 units. Example 22, we have a circle here, and that circle has a center of C, negative 1, 2, and point B has the coordinates 3, 1, and that is a point on the circle. It says first find vector BC, and we're going to go take point C, its components, negative 1, 2, and subtract the components for B, 3, 1. When we do that, we get negative 4, 1. Then it says coordinates of A. Well, AB is called a diameter. So if I'm trying to find those the coordinates of A, basically whatever the vector is to go from B to C, I'm just going to apply that same vector from point C, and that'll get me to A because they're both radii. So if vector BC has the coordinates negative 4, 1, that means I'm going to go negative 4 in the x direction, and I'm going to go up 1 in the y direction from there. So that should put me at negative 5, 3. And there we see, there we kind of see negative 5, 3 are the coordinates of point A. Looking at the example 23 here, we're finding the coordinates of C and D, and notice that the distance from A to B is the same as the distance from B to C is the same as the distance from C to D. So we can just apply that same analysis there. Whatever vector AB is can be applied from B to get us to C. So AB is 1, 3, negative 1. Notice we're in 3 dimensions here. Now if I apply that same vector to point B, then I can find point C. So I'm going to add 1 to negative 1, giving me 0. That means the x component of C is 0. I'm going to add 3 to negative 2, giving me the y component as 1. And I'm going to subtract 1 from 2, and I'm going to get the z coordinate or z component of 1. So there, that gives me point C is 0, 1, 1. Apply that same thing, that same AB vector to point C, and I'll end up getting whatever point D is. So I'll do that. I end up getting 1 plus 1 is 1. Notice there's the 1 right there. 3 plus 1 gives me 4. Negative 1 plus 1 gives me 0. Now you'll notice they're showing it slightly differently here to find out what those points are. Here in this case, they're saying OD, the vector OD from the origin to point D, is OA, meaning how I get to this point here, plus 3 ABs. 1, 2, 3 ABs. Just a different way to get the same point there. All right. Last example here, looking at example 24, and it says we have a parallelogram, ABCD. So let's take a look at that parallelogram. We know parallelograms are going to have parallel and congruent opposite sides. That'll help us out in this case. In this particular question, they're trying to get us to find the coordinates of point C, right here, down in the corner. Now, if I can figure out what vector AB is, I can just apply that same vector AB to point D, and then it'll get me to the components of point C over here. So, vector AB, how do I find that? Well, to go from negative 1 to 2, that's adding 3. If I go from 2 to 0, that's subtracting 2. And if I go from 1 to negative 1, that's also subtracting 2. So I'm going to apply that same vector, 3, negative 2, negative 2, to this point D to get to point C over here. So I'm going to do 3 plus 3, get me a x component of 6. And then I'm going to subtract 2 from the y. 1 minus 2 gives me a b value here of negative 1. And I'm going to subtract 2 from the 4 to get a c value of 2. So therefore, the point C has the coordinates or the components 6, negative 1, 2. All right, that's it for this video here. Kind of a lengthy homework assignment. We're going to take a look at page 291, number 3 to 30 by 3s. So it's only 10 questions, but it might take you a little bit of time. Let me know if you have any questions. You want me to go over any. Hope you guys have a great day, and talk to you soon.